Okay, here is the Boy Scout story, already done, pretty much put together. I have 12 Boy Scouts. 12 Boy Scouts. They pick 132 pineapples. How many did each Boy Scout get? We're gonna divide them up equally. Now, I could do this. And you know what? Here's what I'm gonna do. I'm gonna get my Boy Scouts out so we can really see this. And no symbol to start off when I first tell the story. There's 3 Boy Scouts, 6 Boy Scouts. Oh wait a minute. Here's a Boy Scout. There's a tall Boy Scout. There's Kareem. And there's Magic. Here's some more guys that showed up in uniform. Here's the alien Boy Scout. He's green. Let's see here. So there's 12 Boy Scouts. 4, 8, 12. So then I counted it very quickly, didn't I? All right. Could I pass these out one at a time? Whoa. Oh man, it's gonna take forever. Well, and each one gets. Oh, wait. Can you think of a faster way to pass them out? Watch this. Oh, each Boy Scout just got 10 each. See that? How many do I have left? Let's look here. I didn't pass out these guys. How many left? So first I passed out 120, then I have 12 left. Done. Look at that. And I use this just to start off the first time. Don't put them in there. Just using your imagination, those are Boy Scouts. So it's really easy to see, oh, all of them get, like, because people get involved with this rectangle and they think, oh, they're just counting the edges. Well, it's always 12 across. It's always 11 down. And that I can see now in my Boy Scout story that this guy gets 11. Over here, what was his name? Kareem. He gets 11. Magic gets 11. The alien guy gets 11. Everybody gets 11. Very simple to see. Now, I can make my symbols, and let's get rid of these guys since the Boy Scouts have served their purpose. Let us just take a look at this rectangle now. And of course I can see that if I have a rectangle where it's 132, one side is 12 Boy Scouts. What's the other side? What's the down? Has to be 11. And there it is. Oh, now we're doing long division. Oh, but the teacher doesn't like that because you just put 11, you might have been cheating. What's this thing about blocks? And, you know, maybe you see this on their page. And they say, well, I showed my work. For a lot of teachers, that's not showing your work. You need to show your work. All right, so what are we going to do? Let's show our work and see how it exactly mirrors this block, right? These blocks are exactly what's going on. And I could do it like that. Right? And I'm 12 across and 11, and I could blend the symbols. But anyway, what I'm going to do very quickly and easily is show you that first I go along 10. And there's other videos here, but I'm making this special for the division page with base 10 blocks. From here to here is 10. So I go across 120. And there's a line there. 120. We're just keeping track of subtraction. There's the line. There's the line. Now, it's 120. It's not 12. We don't put an arrow there because 10 times 12 is 120. There they are. Now, I have what's left. Well, what's left was 12. Remember, I told you first we passed out that first 120 fast, and then we had 12 left, and then we passed those out. But I'm not done here. Now, if I just put 10, I haven't passed them all out. I have to go down one more. Right there. 1 times 12 is 12. Nothing left. Now I'm going to throw this in very quickly just to show you. What if I had 133? Actually, I shouldn't have erased all that. But that's okay. Well, if I have 133, still got 12 Boy Scouts. 133. I'm still going to pass out 11. I'm still going to have 120. I'm going to have 13 left now. Everybody down here, we're counting underneath the line, is 13. And then I pass out 12 more. And darn it, I have 1 that remains outside. So I could put remainder 1 over here. Or I could start talking about fractions and say, what if I really wanted to pass that out, that pineapple? What would I have to do? Well, I'd have to get a knife, and I'd have to take this one pineapple, use my imagination, that's a pineapple right there, and cut it up. How many pieces? Any 5-year-old can tell you, into 12 pieces. Why 12 pieces? Because there's 12 Boy Scouts. Done. Super easy. There's the Boy Scout story. Now, how about the cinnamon roll story? Let's set that up. Alright, time for the cinnamon roll story. 23 students. Get that out of the way. 23 students. 276 delicious, smelly cinnamon rolls. You know how the cinnamon rolls smell when they're baking and so forth. How many does each kid get if there's 276 cinnamon rolls and there's 23 students and we want to divide them up equally? Well, the lady's going to be even smart. She's going to make a pan where 276 cinnamon rolls fit in there, and they're going to be 23 across, and everybody's going to get the same size cinnamon roll. And they're going to be little tiny bite-sized cinnamon rolls. So let's use our imagination. These are the cinnamon rolls. They'd be bigger than that, but you know what I mean. We're going to use our imagination. These are our cinnamon rolls. Well, how far across does it have to be? 23. We're going to make a rectangle that's 23 across. Don't need the students up here. You could get them out if you wanted to, but let's just 23. 2 10s and 3. I'm fast because I'm an adult, but little kids might take a little bit longer. How many's left when I put 23 across? Oh. See, and you see the 10? Okay. So, just counting. The only skill you need. 1, 2, 3, 4. 4 10s and 6. We have a name for 4 10s and 6. That's 46. Could I pass them out over here? Well, if I pass them out like that, that's not going to hit. Let's see how much I put 2 there. Let the little kids figure it out. Give them some time. They'll get it. Oh, look, that leaves a space for my 6 cinnamon rolls. And now I'm done. Let's talk about what I just did. Now, I can look at that very easily and see, oh, look, over here, this kid would get 12. This kid would get 12. This kid, they all get a dozen each. Doesn't that work out nicely? And I'm done. Oh, no, I'm not done because you want to see the work. Right? Okay. And again, I could draw a little crutch. I could draw a little picture here. And let's see here. The other guys fit down here. And you see we skip counting 2, 4, and 3 more, 7. Getting add-ins, all that. Now I'm just going to write underneath. What do we do? First we passed out 230 because 10 times 23, 230. Then we had to count up what was left. 1, 2, 3, 4, and 6, 46. How many 23s and 46? This is why the long division is hard. But when you can see it, it's super easy. You see there's a 23, there's another 23. See it? There's 2 23s there hiding. If you look carefully, split these guys apart, and you can see that there's a 23 and there's another 23. 2 rows of 23 right there. 23 times 2, 46. Nothing left. Works out perfectly. Now let's flip the blocks over. See how easy this is? One story about Boy Scouts, one story about cinnamon rolls. Now you've got the concept. It's easy. Let's change this around. I'm just going to flip the blocks over. Okay, and we'll start off with this, the Boy Scout story. Flipping our blocks over. 12 Boy Scouts. But now we don't know. Now we can make it any Boy Scouts. Get these out of here for the time being. And now I'm just going to say, like I said, algebra. Gotta do some algebra. X squared plus 3x plus 2. One side is x plus 2. See it? The other side has to be x plus 1. Has to be. Can we do the math underneath? Sure we can. X times, that's just x plus 2, x times. X plus 2, x times is an x squared and 2x. Now there's nothing there, really. But when we do base 10, this is why people like algebra better. What's left down there? Oh, an x plus 2. Don't need the 1. So can you see it's just 1x? So of course it's plus 1, so just 1 times x plus 2. Done. There's my drawing. It's exactly the same if I was doing base 10. 10 plus 2. But this is if I know x is 10. If I do the Boy Scout story. What if x was 5? It'll still work. What if x is 3? It'll still work. What if x is 7? And then we can start getting the concept of f of x and so forth in there. And I'll leave that for you to do another time, because this is supposed to be basic division. But now we can build any rectangles. And I can just put, that'll be the next step up. We know when x is 10 that it's 10 plus 2, and this is 132, and this is 11. But what if it's 5? Well, then this is 7, this is 6, And I'll bet you that's 42 in there, because 6 times 7 is 42. If it's 8, then this is 10, and that's 9, right? If this is x is 3, are you following me? X is 3, 3 plus 2 is 5, 3 plus 1 is 4. 5, 4, this must be 20. It'll work for every problem. All right, let's get bigger. And that's just substituting various values of x in, right? Okay, very quickly. You know what, I'm going to grab a couple of 3's just because it's faster and easier to do that than have all these units running around. So now what do I have? Now, can you count it? Very simple. 2x squared, 7x, and 6. So let's write that out. Let's make room over here. 2x squared plus 7x plus 6. One side is 2x plus 3. The symbols are lacking a little bit. The other side has to be x plus 2. And we can do the math again. Just counting. Kids will tell you this is way easier, teachers. My pen is starting to die. Okay. What do I have there? Well, I have 2x squared, because x times 2x is 2x squared, and x times 3 gives me 3x. What's left? I have to count all the way to 4. 1, 2, 3, 4x. I'm just counting, and 6. I have to count. Oh, I got off of his hand. Right. 5 and 1 more. So, can you see the 2x plus 3's there? Let's space them out so we can see the 2x plus 3's. That there's 2x plus 3's there. There's one. There's another one. 2 times down gives me 4x. Done. How easy is this? And you see, we get add-ins for 7 in the process. They just come along for the ride. We get 2 times 3, so we get a little baby multiplication there. And again, if it's 10, then this is 23, and this is 12, and this is 276. But what if, right, our function f of x is 2x squared plus 7x plus 6. Actually, that's not the function. The function is a division function. But anyway, all right. But let's just say it was just that part, and get rid of everything else, and I can substitute my values in there if it's a division problem. But let's say, what if x was the same thing as 5? Well, you know what? It's a whole lot easier to say, this is why we factor these, to say 2x plus 3 times x plus 2, which were the two sides of my rectangle, if you recall from just a second ago. 2x plus 3, x plus 2. And I'll skip all the stuff underneath for the time being. Like I said, I have to throw some algebra in. What if x is 5? Well, that's 10, that's 13. What if x is 5? Well, that's 7. Well, 7 times 13, 91. And I could figure it out that 5 times 5 is 25, and 2 of them is 50, and 35 more, and 6 is 91. See, it works for every one of them. Right? Those are just the factors. And we could put in for 3, we could put in 5. This is the beauty of the algebra. But that's advanced. That'll tell you where we're going. Mostly you just want to do a story about Boy Scouts, a story about cinnamon rolls, and you're done. But a quick video here where we just throw it in, and this is going to be all spliced up together because the battery kept dying and so on and so forth. But very simple mathematics. And again, for you teachers with the little kids, the first graders and the second graders, they can do this. In fact, they have fun doing it. They enjoy it. They ask for the algebra. And you are teaching them their add-ins and multiplication and how to count. Right? You do more problems and faster and easier using the blocks, and you'll see that you get more add-ins. When I can go faster and faster. Oh look, what's my add? My add-in for 9, and over here I get 20. And the whole thing, what do I have? You count it up. Super easy and fast. If I'm in base x, it's x squared, 9x, and 20. But if I'm in base 10, oh, see, now we got some 10s hiding with the units. And let's flip everybody over. Oh dear. Just got to do some counting. So, you know, when we've stepped up, we've gone up a couple of degrees of difficulty because I have compound all over the place. All right, so let's see here. Let's just do it quickly, because people always say, well, yeah, but can I do this? Can I do that? What of course. And the idea is you don't want to do all of them. You want to get the concept down. So let's see here. I know the two sides. The two sides are going to be 14 across. How many down? Oh, excuse me, 15 across. And 14 down. How many in the whole rectangle? Well, if you know your multiplication tables, that'll be really easy. If you don't know your multiplication tables out past 10 or 12, because most people don't, then we'd have to do some math here. And all I'm going to do is I'm going to count up. I have 20, and then I have 60, and then I have 110, 210. 15 is contained in 210 14 times. If I want to see the math. What's left over here? What's 40 and 20? Oh, 60. What's 4 times 15? Sure enough, 60. Done. Different way of looking at things, guys. May take you a minute to digest it, but there you go. Done. All right. More than you needed for a basic page, but there is the concept. You need to know where you're going. This is the problem with the teachers of mathematics for the little kids, is that the elementary and primary school educators, they are required to take the least amount of math of any degree you can get out of university, pretty much. And it's showing, and this is the problem. So we need to put more math back in for the little kids. And the teachers of mathematics have to be able to keep up. For you homeschoolers, can you see how powerful this can be? All right. Crewton Ramone's houseofmath.com for more.